morning, everyone. Today I'm going to start chapter 2, data abstraction. The learning objectives of this lesson: what is abstract data structures, abstract data type, difference between concrete and abstract implementation, pairs, data abstraction in structure. Data abstraction introduction. I think most of you know what is data. In 11th standard you learned. Data is a collection of raw facts. Abstraction. Abstraction means hiding the details, right? Data abstraction is a powerful concept in computer science that allows programmers to treat codes as objects. Codes is nothing but programs. So you consider programs as an object, right? For example, car object, pencil object, people object, etc. Programmers need not to worry about how code is implemented. They have just to know what it does. See, for example, I think most of you are using smartphone, right? So you download some app and you use it, right? Suppose if it is not working, what you will do? You just uninstall it. That's it. You don't worry about why it is not working, etc. Right? So this is especially important when several people are doing a project. See, as I told here, you consider code as an object. So when you do a project, the one person will not do the complete project. The project will be divided in modules, right? So like last chapter, you learned about subroutines, right? Like that, each and every subroutines will be given to different programmers, right? Each and every programmers will do their task. So one programmer will not bother about other programmers' task, whether it is working or how it is performed, etc. Right? So with data abstraction, your group members won't have to read through every line of your code to understand. They can just assume that it does work. That's all. They don't bother about the lines of the code, how much memory it occupies, etc. Understood? So abstraction provides modularity. Modularity means splitting a program into many modules. Just now I told you, one module it will be split into so many programs, and each programs will be given to each module will be given to different programmers, right? Classes, structure are representation of for abstract data types. Okay. Now, what is abstract data type? So, abstract data types, ADT, is a type or class. It is a type or class for objects whose behavior is defined by a set of values and set of operations. Set of values is nothing but attributes. Set of operations are nothing but functions. Understood? Right? So, the definition of ADT only mentions what operations are to be performed, but not how these operations will be implemented. So, I think in last video, I explained about class program, right? In the class program, I told you, the interface will just define the class, right? Okay, it will not actually implement anything, right? So it does not specify how data will be organized in memory and what algorithm will be used for implementing the operations. It is abstract, it is hidden because it gives an implementation independent view. See the definition for abstraction. The process of providing only the essentials and hiding the details is known as abstraction. Only what you should know, you will know. Remaining things are hidden. Understood? See, when you use a particular software, right, you should know what output you get, how to use it, that's all. You don't bother about which language they use to write the program and what type of loop they used, etc. Understood now? So, you can see that these definitions do not specify how these ADT will be represented and how the operation will be carried out. There are different ways to implement an ADT. There are different ways. Okay, for example, the list ADT can be implemented using singly linked list or doubly linked list, right? So this I'm going to explain through example. Okay, I'll open that. Before that, I will explain data abstraction. Data is nothing but raw facts. Abstraction, code as objects. Okay, as I told, program will be considered as an object. That's why it is called object-oriented programming language, right? So objects are nothing but class. Class will have attributes and functions. Is it clear, everyone? Now, what is data type? Int a is equal to 7. Data type. Int is a data type. A is nothing but a variable. 7 is nothing but constant. I'll give you an example. Object fan. We will take example fan. It has got attributes and functions. Behavior. Behavior are called as functions. Now, what will be the attributes? Size, shape, color, type, etc. These are attributes, right? Function. What function you can do using fan? You can switch on the fan, you can switch off the fan, right? But implementation, how it works, are hidden from you. I think now it is very clear for you, right? Now I'm going to explain different ways of implementation and ADT. Singly linked list, doubly linked list. Now, before going to that, we will see what is an array. Array is a collection of values stored under a common name. For example, here you see mark 70, 62, 57, 52, 77, 45, 33, and 77. Understood? So, let us take an array. Normally, we store the list of values in an array. Mark is the name of the array, and it is indexed starting from 0. As you all know, array starts from 0. So, 0, 1, 2, 3, 4, 5, 6. These are index. Right? Now, see, it will be stored in continuous memory location. See, continuous memory location. So, using the index, using this index, we can go from 70 to 77, 77 to 70 because everything is stored continuously. Is it clear? Suppose if we want to store in different memory location, that means values, I want to store it in different memory locations. I cannot go from starting to end and end to starting if it is not continuous, right? So we will see using singly linked list how we will do it. Suppose if you want to store a different memory location using a singly or doubly linked list, first we will see singly linked list. So 30 is stored. See here what happens. Here each field is called node. Consists of 2 boxes, fields we can say. Okay, so this is one memory location, this is another one, this is another one. Different memory location. So 30 and 40 and 37. See here, the address of 40 is stored next to 30. Same way, address of 37 is stored next to 40. So from here, even though it is in different memory location, I can go from here to here. 30, 40, 37 I can go. But the disadvantage is from 37 I cannot go to 30. You understood? Because only this memory address I know. But from here I cannot go. See here. So this goes on till the data gets over. So in singly linked list, we can go from first element to last element, but we cannot start from the last element to first element. Because here you see there is no memory address because it stops here. So that is a disadvantage of singly linked list. Right? Now we will see doubly linked list. Here you see 3 fields are there. Right? Here there is no memory address. And here there is no memory address, starting and ending. But here you see the second element, 30. And here the address of 40 will be stored. And here the address of 30 will be stored. So there is a link between this and this. Understood? So similarly, here also you see the address of 70 is stored here. Address of 40 is stored here. So there is link. So from here till here I can move. From here till here I can move. So here each field will have 3 fields. First field is not having any address. Second field address will be stored in the second linked list. And the second field, second linked list address will be stored in the first linked list like this. So I can go from 30 to 70 as well as 70 to 30. Is it clear now? Okay, right? Next we will see So the example for ADT is singly linked list and doubly linked list. Similarly, stacks ADT and queue ADT can be implemented using list, right? We will see that also. See, stack. This is stack. So this is called last in, first out. See, 30, 40, 50, 60. So what happened? 30 will be moved first, then 40, 50, 60. So last in, first out. But here you see in queue, first in, first out. See, I have sent 20 first. So 20 went first, then 30, and then 40, and then 50, and then 60. So these are called stacks and queues, right? These are the concept in any language, C++ or Java, Fortran, Python. These are the concepts, right? Singly linked list, doubly linked list. Okay, these are the concepts you should know. Fine. Now, next is data abstraction. Replicate how we think about the world. For example, when you want to drive a car, you don't need to know how the engine will be built or what kind of material the tires are made of. You just have to know how to turn the wheel and press the gas pedal. That is accelerator. Is it clear, everyone? So all the other things are hidden. You should know how to drive the car. You don't need to worry how each and every parts of the engine works, how the car is made, etc. You don't need to worry because those are hidden. Those are abstract from you. So to facilitate data abstraction, you will need to create two types of functions. So to facilitate the abstraction, you have to create two functions. One is constructor and another one is selector. One is constructor and another one is selector. So the next topic will be constructor and selector. Constructors and selectors. To facilitate data abstraction, you will need to create two types of function, constructors and selectors. Now, what are constructors? Constructors are functions that build the abstract data type. So constructors, what it will do, it will build the abstract data type, which is nothing but object, right? Selectors are functions that retrieve the information from the data type. Okay, so selectors will retrieve the data from constructor. For example, say you have an abstract data type called city, that is ADT, city object. A city object will hold the city's name, and its latitude and longitude. You know what is latitude and longitude? Both latitude and longitude are angles measured with the center of the earth as an origin. So you can, if you get latitude and longitude of any city, the exact point you can get it, right? Exact place. So it will be expressed in degrees and minutes. Okay. So to create a city object, you did use a function like city, this is ADT, which is nothing but object, and make city, you are going to get make city name, latitude and longitude. So this is nothing but constructor. So here you have seen, see, constructors are the function that build the abstract data type. So you are building abstract data type. So to extract the information of a city object, you would use functions like get name city, get latitude city, get longitude city. So these are selectors. So these are selectors. The following pseudocode will compute the distance between two city objects. One is name of the function is distance, city1, city2. Okay, so this is constructor parameter. City1, city2 are parameters. So LT1, latitude 1, comma latitude, longitude 1. So latitude 1, so get latitude city, whatever you are getting, that will be stored in LT1. Get longitude city, whatever you are getting, that will be stored in LG1. Similarly, another city. So you are going to find the distance between these two cities, right? Same way, get latitude city2 will be stored in LT2. Get longitude city2 will be stored in LG2. Finally, it will calculate this, and this is called implementation. You don't need to worry how it functions, right? Only You have to see what output you get. That's it. Okay. So in the above code, read distance function, get latitude function, and get longitude functions as functions, and read it as latitude and longitude. That is LT as latitude, LG as longitude. Read colon equal to as assigned as or becomes. So how you have to call this? LT1 comma LG1 becomes get latitude city1 comma get longitude city1. So it is read as LT1 becomes a value of get latitude city1. LG1 becomes a value of get longitude city1. Have you understood? Right? So notice that you don't need to know how these functions were implemented. So you don't need to know these things, how it gets a latitude and longitude, where it stores and how it calculates, nothing, right? So you are assuming that someone else has defined them for us. That means someone had written program for you and you're going to use the program, like how you download app in your smartphone and how you use it, right? So it's okay if the end user is, we are the end user, does not know how functions were implemented. However, the functions still have to be defined by someone. Someone should write it. Then only you can use it, right? Let us identify the constructors and selectors in the above code. As you already know that constructors are the function that builds the abstract data type. This is the abstract data type. Constructors builds the abstract data type. In the above pseudocode, the functions which creates the object of the city is constructor. This is constructor. So this is constructor. Okay. Here, make city name comma lat comma long is the constructor which creates the object city. So this creates the object city, that is ADT, abstract data type. Here, make city name comma lat comma long is the constructor which creates a object city. Now here, this is pictorially they explain. See here. So make city is an object. So it gets both latitude and longitude. Okay, when you pass the parameter, you are getting the city exact location, right? So selectors are nothing but the functions that retrieve the information from the data type. Therefore, the above code get name city, it will get the city name, and get latitude, it will get the latitude, and get longitude, it will get the longitude from the constructor. So are the selectors because these functions extract the information from city object. Same thing in pictorially they have shown. City, the value will be passed as a parameter. A city value will be passed as a parameter. Here you see this will get the city name, this will get the city latitude, this will get the city longitude. Now let us consider one more example to identify the constructor and selector for slope. I think you all know what is slope. At least you must have more than one point, then only you can calculate slope. So here you see constructor, make points x comma y. So this is constructor. This is constructor. Return x, y, and here you see selector. First selector. This is selector 1. This is selector 2. Fine. So using this selector, you are going to get x coordinate. Using this selector, you are going to get y coordinates. So x coordinate point, return 0.0. Selector y coordinate point, return 0.1. Understood? So this will calculate slope. Right? Note, data abstraction is supported by defining an abstract data type, ADT, which is a collection of constructors and selectors. Constructors creates an object, as you all know, city object, bundling together different pieces of information, while the selectors extract individual pieces of information from the object. Is it clear? So, in this video, I started chapter 2 and I started asking questions about data, and then I explained about abstract data type. That is a process of providing only the essentials and hiding the details is known as abstraction. And then I explained about constructors and selectors, and I explained about object, etc. Okay. So next class, I will start representation of abstract data type using relational numbers. Okay. go through the video. Still, if you have any doubt, you can ask me. Okay, children? Thank you.